Hello, my name is Carlos Jimenez and I'll be doing the Chapter 17 video exam. So the question reads, an outdoor outfitter estimates its total production of 160-meter climbing ropes is f of xy equals 4x to the exponent of 0.75, y to the exponent of 0.25, where x is the numbers of units of labor and y is the numbers of units of capital utilized. If $12,800,000 is available for labor and capital, and if the firm's costs are $800 per unit of labor and $1,600 per unit of capital, how many units of each will give the maximum production? How many 160-meter ropes will be produced? So first things first, what I'm going to write is the f of x, y equals 4x 0.75, y 0.25, and then I'm going to find my constraint. So this constraint will be, the x will be 800x per unit. It's going to be 800x plus the 1600 y per unit of capital, 1600 y equals 12,800,000. See that there correctly. Now I gotta write it down as a g of xy. G of xy will be 800x plus 1600 y minus 12,800,000 equals 0. Would be that right there. So now we gotta do the Lagrange function. So the Lagrange function will go as f of x, y, lambda will be 4x 0.75, y 0.25 minus lambda parentheses 800x plus 1600y minus 12,800,000. So now we're gonna clean this up a little bit. So it's going to be 4x to the exponent of 75, y to the exponent of 0.25 minus 800 lambda x minus 1600 minus 1600 lambda y plus 12,800,000 lambda. I was about to sneeze there. So this should be the f of xy lambda. So that should be right there. My Lagrange function. My lambda may not be perfect, but it's the best what I could do. So now my next step is finding the partial derivatives. So I will be doing f of x equals, let's see, we got 4x to the exponent of 75. So it's going to be 3x negative 0.25. And then y to the exponent of 25 minus 800 lambda. I got it right there. Oops. Right there. But let's clean this up. We're gonna be doing, since we can't have exponents, negative exponents, we're gonna bring the 3x down. So it's gonna be y 0.25 over 3x 0.25 minus 800 lambda. So that's gonna be my f of x right there. So now let's find f of y. F of y will be, let's see, 4x 0.75 times the y to the exponent of 0.25. So it's going to be 4x 0.75 and then 0.25 y to the negative exponent of 0.75 minus 16 lambda. But let's clean this up a bit because we can't have negative exponents. So what we're gonna do is we're gonna bring to the 0.25y down. So it's going to be 4x 0.75, or actually hold on here a second. If I bring that down, then that means that it multiplies to the 0.4. I'm sorry, it's going to be 3x 0.75, and then I'll be having y to the exponent of 75.75 minus 16 L f of y. So that's going to be my f of y right there. There you go. And now we're going to find f of lambda. F of lambda will be negative 800 x minus 1600 y plus 12,800,000. That is my f of lambda right there. And now we gotta set them equal to 0. Equal to 0. So now I'm gonna find the points. So what we're gonna do is negative 800 lambda equals y to the exponent of 0.25 over 3x 0.25. Now what we're gonna do is lambda equals, we're gonna move over the negative. Well, it's not negative because I already moved it over, so that goes away. I'm gonna move over divided by 800 to the other side. So it's going to be y 0.25 over, let's see, what's 800 times 3? That should be, might as well check on the calculator. It's going to be 2,400 x to the 0.25. See, that's what I found for my, oops, can you see right there? Yeah, for my f of x right there, when I said equal to 0. And then, now for the f of y, let's see here, f of y is going to be 1,600 lambda equals 3x 0.75 actually I might have missed something. Hold on just 1 second. 4 times 0.25. Oh, never mind. Actually on my f of y, oops, it's actually equals, my f of y is going to be x to the exponent of 0.75 over y to the exponent of 75. Just realized that. So we're going to be doing over y 0.75. So now we're going to be dividing 1,600 over lambda equals x. Right over here. And over y 0.75 1,600 y. That's what I found when I did equals 0 for the f of y. I found that it's going to be lambda equals x to the exponent of 0.75 over 1,600 y to the 0.75. So now we're going to try to find either x or y. Flip over because I need more room. So it's actually going to be 3x lambda point what? Y point 0.25 over 400 x to the exponent of 0.25. 0.25. I'm actually going to set that equals to the f of y that we found when we put it to 0. So it's going to be x 0.75 over 1600 y to the 0.75. So that's what I'm doing right now. So I could find either y or x. So what we're going to do is we're going to cross multiply, and it's going to be 1600 y equals 2400, okay, so 2400 x. So now what I'm gonna do is I'm actually gonna divide 1600 y over to 24, well, 1600 over to 2400, so it's gonna be y equals 2400 over 1600 x. So it's 2400, 1600, we're gonna get rid of the zeros, so it's going to be 24 over 16x. So that is, oops, sorry. So that is my y right there. So what I'm gonna do is I am going to plug that into f of lambda. I'm gonna plug that into the y of f of lambda. So f of lambda is going to be, let's see here. Oh, and I also forgot to mention, I also made sure the f of lambda is actually the opposite to the constraint. Oh, where is it at? Let's see. F of lambda. Let's see, f of lambda, the opposite. Yep, yeah, I was right. F of lambda, I was getting myself confused. F of lambda opposite to the d of xy. Right there. So, I had to make sure. Let's see here. 18-minute video. I gotta keep on flipping over. F of lambda. So it's going to be f of lambda equals minus 800x minus 1600 times 24 over 16 plus the 12,800,000. 12,800,000. So that's where I'm plugging it into right there. So now, since I know that 24 over 16, let's see, 24 over 16, that's 1.5. So 24 over 16, so that's 16 times 1.5, that's 24. It's 24, so it's going to be minus 800x minus 2400x equals negative 12,800,000. We're gonna combine like terms. It's gonna be 1200, 24 plus 800, 3200. So it's gonna be negative 3200 equals negative 12,800. Divide that over. See, 12,800,000 divided by 32,000 is going to equal 4,000. So x equals 4,000. So now I'm going to plug that. Be plugging this x equals 4,000 up to the equation that I have right here. So that will find my y. So it's going to be 24,000 times 4,000. 24,000 times 4,000. That's going to be 9,600,000. Well, 9,600,000. 9,600,000, 16, 96,000. So now I'm gonna be dividing the 9,600,000 with 16,000. No, 1,600. I'm sorry. I keep on myself getting confused. Divided by 1,600. I got 6,000 for y. So x equals 4,000, y equals 6,000. Those are the pairs that I found right there. The pairs that I found. So now we have to compare the pairs to see if it's a maximum or minimum. So I'm gonna put here found. Here it is. X equals 4,000. Y equals 6,000. And then I'm gonna do compare. Let's see. We should do y equals 0. Compare. So if we do the g of x and we do y. So the g of x, if we plug in the y, equals 0. If y equals 0, then that means that the rest of the problem will equal 0. I'm sorry, I keep on getting myself confused. F of x is going to equal 0 if we plug in y equals 0. If we plug in y equals 0, let's see, y equals 0, I'm so sorry, let's see, if we do y equals 0, it's going to be 12,800,000 divided by 800. That will be 16,000 for the x. That would be the pairs I'll be comparing. But if I plug that to the f of xy, it's gonna cancel. So that means that the order pairs that I found are bigger. So what I can compute is, let's see, I'm gonna plug in those pairs in f of x, f of xy, f of xy equals 4x, let's see, 4 to the 4,000 to the exponent of 0.75, and then y, which will be 6,000 to the exponent of 0.25. Yep, exponent of 0.25. I'll plug that to the calculator real quick. Sorry, this took long. I was getting myself a little confused, but looks like I got it. I get f of xy equals 17,000. Sorry. Hold on. Sorry. I got that for f of xy equals 17,706.91. So I will conclude that the maximum of 160-meter ropes rope would be 17,706.91 when x equals 4,000 and y equals 6,000. Right there. And so that concludes my video.